Hi listeners, you are welcome to the continuation of our online tutorial class from your students ScoreBooster, your online tutorial provider on JAM, WAEC, NECO and NAPTIP exams. For today's presentation, we shall be discussing the concept of Pascal Principle of transmission of prayer. I am Bangbade AA. Now, before we continue, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to state Pascal Principle. They should also be able to state the mathematical expression for Pascal Principle. Then they should be able to give the examples of application of Pascal Principle. And lastly, they should be able to solve relevant UTME questions relating to Pascal Principle. Now, on to the Pascal Principle of transmission of prayer. When we talk about Pascal Principle states that any prayer applied to a liquid which is confined in a container or vessel will be transmitted equally to all parts of the container. I repeat, Pascal Principle states that any prayer applied to a liquid which is confined in a container or vessel will be transmitted equally to all parts of the container. Now, having understood Pascal Principle, we need to consider the peculiar application of Pascal Principle, which are the hydraulic machines, which work based on the principle of Pascal. Now, under the hydraulic machine, we have examples such as hydraulic press, which is used for lifting heavy loads. Also, we have hydraulic jack, which is normally used for lifting cars. And of course, when we have a flat tire, we normally make use of hydraulic jack in lifting the vehicle up so as to change the wheel or the tire. Also, under the hydraulic machine, we have hydraulic brake, which is normally used in slowing down or stopping a moving automobile. Now, having understood the Pascal Principle and the application which include the hydraulic machine, the next concept we shall be discussing will be on hydraulic prayer. Now, hydraulic prayer will be a prayer generated within hydraulic machine, and in hydraulic prayer, a force ever applied on a small piston of cross-sectional area A will generate a prayer which is force over area, which will be transmitted through the liquid to the large piston of area A. Usually in hydraulic press, you have smaller piston and larger piston. The force generated on the small piston will create a pressure which will later be transmitted to that of larger piston. Now, the larger piston will have upward force which is equal to pressure generated times the area of the larger piston. And of course, we know pressure is equal to force over area, which will now be times area of the larger piston. Then we can collect the like times to get W, which is now the pressure, the force of the larger piston over force of smaller piston will now be equal to area of larger piston over area of smaller piston. Or we can write it as F1 over A1 will be equal to F2 over A2. That is, the pressure of the first piston, which is force over area, will be equal to the pressure of the larger piston. The pressure of smaller piston will be equal to pressure of larger piston. That is, F1 over A1 will be equal to F2 over A2. Now, the hydraulic pressure is thus a force multiplier. That is a simple machine with mechanical advantage to be W over F, which is equal to the ratio of cross-sectional area of the piston. Now on to measurement of pressure, and we use some devices in measuring pressure, one of which is manometer. Manometer measures gas pressure. If the liquid in open arm rises to a height h above that on the other arm, then the pressure of the gas will be equal to Pa plus Hdg. Pa in this case is the atmospheric pressure, while Hdg will be the pressure generated. You know, of course, in our previous lecture, one of the formula for calculating pressure is height times density times acceleration due to gravity. Therefore, in a manometer, the pressure generated will be Pa, that is atmospheric pressure, plus the new pressure generated, which will now be Hdh. Another device for measuring pressure is sphygmomanometer. Sphygmomanometer measures blood pressure, so it's usually used by medical personnel. Another device for measuring pressure is a barometer. Barometer measures atmospheric pressure, and barometer can be of different types, such as simple barometer or torricellium barometer. This usually consists of mercury filled tube inverted into a disc. Another type of barometer is the floating barometer, which is similar to simple barometer, except that a leather bag is used in place of disc mercury. Another type of barometer is the aneroid barometer. Aneroid barometer, which does not make use of mercury or any liquid, is used to measure altitude, that is the height above the sea. Now on to practice question from UTME, and the first question we shall be considering comes from 1985, number 15, and the question goes thus: the areas of the effort and load pistons of a hydraulic pressure are 0.5 meters square and 5 meters square respectively. If the force F1 of 100 Newton is applied on the effort piston, the force F2 on the load is dash. Now we have option A to be 10 Newton, option B to be 100 Newton, option C to be 500 Newton, option D to be 1000 Newton, while option E is 5000 Newton. Now on to solution. The F1 here represents the force on the load, which is equal to 100 Newton as given from the question. Then the F2 represents the force on the effort, which is unknown. That is what they have asked us to calculate. A1 here represents the area of the load, area of the effort, while A2 represents the area of the load, which is 5 meter square. You know, from the question, they said the area of the effort and the load piston of hydraulic pressure are 0.5 meters square. That means area of the effort A1 is 0.5, while area of the load is 5 meters square. Now we have to record that the pressure on the load piston will be equal to pressure on the effort piston, and therefore, you know, the formula for pressure is load over area, or force over area. So in terms of load, it will be load over area, while the pressure of the effort will be effort over area, since both load and effort are force. Then if we substitute for this formula, our load, which is unknown, will now that is L, over area, which is area of the load, which is 5, will be equal to effort, which is 100 Newton, over area of effort, which is 0.5. So if you cross multiply, we have 0.5 L will be equal to 5 times 100. We can make out the subject by dividing both sides by 0.5, and that will give us 5 times 100 divided by 0.5, making our load L to be 1000 Newton, making option D the correct answer for this question. The next question we shall be considering comes from 1995, question 16, and the question goes thus: a hydraulic press has a large circular piston of radius 0.8 meter and a circular plunger of radius 0.2 meter. A force of 500 Newton is exerted by the plunger. Find the force exerted on the piston. We have option A to be 8000 Newton, option B to be 4000 Newton, option C to be 2000 Newton, option D to be 31 Newton. Now on to solution. From the question, the parameters given, you have the radius of the larger circular piston R1, which is 0.8 meter. Then we are also given the radius of the plunger, which is R2, which is equal to 0.2 meter. Then we are given the force exerted by the plunger, that is F1, which is equal to 500 Newton. Why they ask us to find the force on the piston, the force exerted on the piston, that is the force of the larger circular piston. Now, solution to this: as usual, the pressure on the large circular piston will be equal to the pressure on the plunger. So the pressure of the plunger now will be the force of the plunger over area, and that will be 500 divided by pi times 0.2 square. In this case, since we are not given area directly, we can calculate the area from the radius using pi r square, because the area is circular in nature. So in this case, the area of the plunger will be pi times r square, which is 0.2 square. So therefore the pressure will be equal to 500 over pi 0.2 square, which will be equal to the force of the larger piston over the area, which will also be pi 0.8 square. So we can cross multiply. If we cross multiply, in this case we have F2 times pi 0.2 square will be equal to 500 times pi 0.8 square. Then we can make F2 the subject by dividing through by dividing through by pi 0.2, and that will give us F2 equals 500 times pi 0.8 square divided by pi 0.2 square. So pi will cut away pi, and 500 times 0.8 square divided by 0.2 square will give us 8000 Newton, making option A the correct answer for this particular question. The next question we shall be considering comes from 2004, number 15, and the question goes thus: in a hydraulic press, a force of 40 Newton is applied on the effort piston of area 0.4 meter square. If the force exerted on the load piston is 400 Newton, the area of the large piston is dash. So you have option A to be 8 meters square, option B to be 4 meters square, option C to be 28 meters square, while option D is 18 meters square. Now, solution as usual, the first thing is to write out the given parameters. So we are given the force of the effort to be force F1, which is 40 Newton. Then we are given the area of the effort also to be 0.4 meters square. Then we are given the force on the load piston to be 400 Newton, while they ask us to get the area of the large piston, that is the area of the load. Also, the pressure of the load will be equal to pressure on the effort. So therefore the pressure of the effort, which can be expressed as force of the effort over area of the effort, that is F1 over A1, will be equal to pressure of the load, which is F2, the force of the load, over area of the load, which is A2. So in substituting for this, our F1 is 40 Newton over A1, which is 0.4 meters square, equals F2, which is the which is the force of the load, which is given to be 400 Newton, over area of the load, which is unknown. So if we cross multiply, we get 400 Newton times 0.4 will be equal to 40 Newton times A2. We can make A2 the subject of formula by dividing through by 40 Newton, and that will give us A2 equals 400 Newton times 0.4 divided by 40 Newton, making our A2 to be 4 meters square, making option B the correct answer for this question. Now on to practice question from UTME. The first question here for your practice comes from 2005, number 32. And the question goes thus: a force of 200 Newton acts between two objects at a certain distance apart. The value of the force when the distance is half is dash. So you have option A to be 100 Newton, option B to be 200, option C to be 800, while option D is 400. Expected answer here is option C, which is 800 Newton. The second question for your practice comes from 2010, number 12. And the question goes thus: in a hydraulic press, the pump piston exerts a pressure of 100 Pascal on the liquid on the object. What force is exerted in the second piston of cross-sectional area 3 meter square? So we have option A in this case to be 200 Newton, option B to be 100 Newton, option C to be 150 Newton, while option D is 300 Newton. Expected answer here is 300 Newton. That is option D. Now our next video will be on temperature with sample questions and solutions from UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be producing you more interesting lecture on subjects related to UTME and SSC. Thank you.